Welcome, Hornets. In this portion of our video, or in this video, we are looking at one of our most important uses of implicit differentiation, finding equations of tangent lines and finding what dy dx is. Now remember that dy dx is the slope of the tangent line, and we will need to have a point. So if you think about this is something that we've already done and shouldn't be too bad. The issue is that we have two variables in our dy dx as opposed to one. That's all that's really changed. So let's go ahead and begin. We're going to start by thinking about a plan. If I am given my equation and I have an x, it only makes sense to plug in my x. So I'm going to take x equals -3/2, y equals the question. So here we go. If I have my equation 4 times -3/2 squared plus 9y squared equals 36. This is going to give me 9/4, and the 4's are going to reduce, leaving me with 9 plus 9y squared equaling 36. Now the easiest way to approach this, let's make sure you can see it. The easiest way to approach this is to subtract 9 from both sides. Notice I'm left with 9y squared, and this will equal 27. I divide by the 9 on both sides, and y squared equals 3. I now take the square root of this, and that's going to give me an absolute value. So I'm left with plus or minus √3. Now, once we have these 2 points, we're going to have to recognize that we now have at -3/2 two different y values. And it's with that we're going to have to find our slope, dy dx. So if my x is equal to -3/2 and my y is equal to, let's go ahead and start with the positive √3, I'm now going to want to put this into my dy dx. And as I do so, I'm left with -4 times -3/2 divided by 9 times √3. Now, the double negative is going to make it positive. The 2 is going to reduce with the 4, leaving me with 2 times 3 in the numerator. And you'll notice I end up with 6/9 √3. And I'm going to simplify that again, and I'm going to end up with 2/3 √3. Now, if we use x equals -3/2 and y equals -√3, the only thing that's going to change in our dy dx is going to be 3 negatives instead of just 2. And that means that my answer is going to be the exact same thing, but simply opposite. So -3 √3. Now you notice I now have two different slopes. Here's one dy dx, and here's the second dy dx. And we're going to want to use the first and the second with our points to find the equations of the tangent line. So I have x equals, let's make sure you can see this, x equals -3/2, my y equaling √3, and my m equaling 2/3 √3. So we're going to put this into point slope form. Y minus √3 equals 2/3 √3, and I have x plus 3/2. Well, the second equation uses the similar information because that's our first answer. And we now have our x equals -3/2, y equals -√3, and our slope being -2/3 √3. Y plus √3 is equal to -2/3 √3 times x plus 3/2. And this is my second answer that we are looking for. So be aware, there's a lot going on here. And that's why these problems tend to be difficult. We start off by having to figure out what y is equal to. And as we go through our solving process by plugging in the x, we find one or two y values. Now we don't know whether one or both will work, and we have to plug them into our slope. So we use the slope formula dy dx, we plug it in and simplify, and if possible, we look for any relationships that make our job easier so we don't have to do more work. Once we have the point with x and y and our slopes, gather them up and put them into point slope formula for our first equation and our second. There you have it. Please enjoy. You're about to do one on the Google Forms, so just relax. And for those of you who aren't doing that, have a good day. Take care. Thank you.